All right, class. Today, we will be going over my missed questions on the math test. I'll be teaching you all how to do it. I'll be teaching myself how to do it. I've already taught myself how to do it. And now you all get to learn with me. So the first question we missed was here, question 1, part D. Got all these right, but we're going to have to go over some stuff down here. Looks like I didn't really know what was going on. I got confused. Not to fear, now I know what to do. So I'm just going to draw you the graph here. I'll draw it. You don't get to see. We got a 1. It looks like it goes up about 4. You got down 4. 1, 2, 3, 4, 5. Good enough. All right. So we got our graph. And what the question is asking of us, let's get a little shot here. For the technical errors. For the graph of the function j of x below, find the following. So we need to find, first of all, look, bad, got that wrong. We need to find the limit as x approaches infinity. So, if we draw this up here, you have an arc. He goes up about there and comes down about there. You have this guy. He comes up and then he comes down and he squiggles. That's on that line, by the way. And then you have this one. He comes down and he goes like this. So let's just get for visual. I'm not a very good artist, but you get the idea. He's squiggling on this line. So we're trying to find x, the limit of j of x as x approaches infinity. So when you look at the graph, to find the limit of j of x as x approaches infinity, you need to find where x is approaching infinity. So that's when it goes off the graph to the right? And what's happening here is it's oscillating between 2. It's oscillating on the line 2. And that means, basically, that as it approaches infinity, it is equal to 2. That's just the pattern x presents. So this is not negative infinity as I put. This is, in fact, 2. Now, next question. I got this one right, but I'll teach y'all anyway. Limit j of x as x approaches 2 from the left, right? So now instead of going off in any direction of the graph, we're staying here because we have 2 on this graph. So if we look, as x approaches 2 up here, this is 2. Let's draw a dotted line right here. What is happening is, from the left, right? So it looks like this. Limit j of x as x approaches infinity. Or no. As x approaches 2 from the left. That's a negative from the left. So this is a directional indicator. It means that we're not looking at just 2. We're looking at what happens from the left as we're approaching 2. So as we can see, I got that right. This line, approaching 2 from the left, goes down, continues to negative infinity. You get infinitely close to 2. You get infinitely closer to negative infinity. Now, limit j of x as x approaches 2 normally. As you can see here, I got this wrong. I said infinity is not the answer because it is split. We have an asymptote here. But instead of going in one direction, it's splitting the direction. There is no singular infinity or negative infinity because they split along the line. So that is not infinity as I put. It does not exist. We can forget about it. The last question. We need to find the vertical and horizontal asymptotes. So let's write that here. V, A, and horizontal asymptotes. So what an asymptote is, basically, on the graph, is a point at which you get infinitely close to a number as you approach any number, but you never touch it. So right here, we have a horizontal asymptote. You get infinitely close to -1, or you oscillate between it, but you never land on it. It continues in that pattern for infinity. So for our first horizontal asymptote, we have -1. Now, on my test, that's all I said, which is wrong, because you have another one up here at 2. As I said earlier, we were finding the limit as x approaches infinity. It oscillates on the line 2. So this is also a horizontal asymptote. And then if we look at our vertical asymptotes, we have this one right here that we've already examined. Oh, I wrote it there. We also need it here. You have -1 and 2, and right here at 2 again for the vertical, and also 0. You can see they both get infinitely close to 0, but they never touch it, and they go down to -infinity. So 2 and 0. That's how to do question 1, part D.